Good morning, friends. In this video, we will study about detectors used in UV visible spectroscopy. These detectors measure the intensity of electromagnetic radiation. For this purpose, photoelectric detectors are used in UV visible spectroscopy. The detectors used should give a linear response to the light input, and these detectors should not suffer from drift or fatigue. The detectors used in UV visible spectroscopy are phototubes, photomultipliers, photodiodes, photovoltaic cells or barrier layer cells. These photovoltaic cells or barrier layer cells lack sensitivity, so their usage is restricted to colorimeters and flame photometers. First, we will study about phototubes. This is the diagram of a phototube. It consists of a sensitive metal surface which acts as a cathode and an anode, enclosed in a high vacuum envelope. This cathode is made of metals like potassium or cesium. To make cathode more sensitive, composite coatings such as cesium oxide or silver oxide are used. When a sufficiently high potential is applied between cathode and anode, the electrons will be liberated from cathode by the action of light, and those electrons will reach the anode, such that a photocurrent is generated in the phototube, which has a linear response to the intensity of light input. Next, we will study about photomultipliers. This is the diagram of a photomultiplier. It consists of a photocathode and a series of anodes at a gradually increasing potential. These 1, 2, 3, 4, 5, 6, 7 are the anodes. The photocathode and anodes are enclosed in one bulb in these photomultipliers. When light falls on a photocathode, electrons are liberated from the photocathode and they reach the anode 1 and liberate more electrons, and they reach anode 2, which is at higher potential than the anode 1. This process continues until the last anode, such that final photocurrent, which is 10 to the power of 6 to 10 to the power of 8 times greater than the primary current, is generated, which shows a linear response with increase in the intensity of light. Next, we will study about photodiodes. This is the image of a photodiode. It consists of depletion layer and p side and n side. P side has holes and n side has electrons and a battery and also a resistor. This resistor will limit the current that is flowing through the circuit, which avoids the damage of photodiode. This photodiode is a PN junction diode and it works in reverse bias condition. It is because we will tell that it works in reverse bias condition because P side of the photodiode is connected to the negative terminal of the battery and N side of the photodiode is connected to the positive terminal of the battery. This photodiode consumes light energy and produces electric current. This works in reverse bias condition as we told earlier. When light is incident on the surface of diode, it generates electron-hole pair and that will move in the circuit. It gives current which has a linear response with the intensity of light input. Such that we measure the intensity of electromagnetic radiation in UV visible spectroscopy. Here, let's answer few questions related to this topic. First one, in phototubes, these coatings increase the sensitivity of cathode. A. Lithium oxide, B. Cesium oxide, C. Calcium oxide, D. Zinc oxide. You can pause the video and guess the correct answer. The answer is B. Cesium oxide. In phototubes, cesium oxide coatings increase the sensitivity of cathode. And also silver oxide coatings can be used to increase the sensitivity of cathode. Second one, in photomultiplier, when light is incident on photocathode, these are liberated. A. Photons, B. Electrons, C. Neutrons. Answer is B. Electrons. Not only in photomultiplier, in phototube also, when light is incident on photocathode, electrons are liberated. Third one, photodiodes work in reverse bias condition. Is this statement is true or false? This statement is true. Photodiodes work in reverse bias condition, which means that P side of the photodiode is connected to the negative terminal of battery and N side of the photodiode is connected to the positive terminal of the battery. Thank you for watching this video.